Hi grade 9s. Today we are going to do a lesson on finding like terms symbolically. We used algebra tiles last class. This class we're going to do it without algebra tiles. We're going to do it with algebra. All right? So let's go ahead and get right down to it. If we look at an algebraic expression, the terms are said to be like terms if they contain the exact same variables with the exact same exponents. Consider the expression 2ab plus 3a squared b to the exponent 3 minus 4a squared to the exponent 4b minus a squared b cubed plus 5a cubed b cubed plus 3ab. In that expression, there's two pairs of like terms. And, as you've probably already noticed, they're highlighted for your convenience. The yellow ones are like terms because they both have a, b, both with an exponent of 1. The other ones that are also like terms are the a squared b cubes. The other two terms do not have a dance partner, and they can't be combined with another term to make like terms. So just like when we did the algebra tiles, it does make sense to rearrange the equation and group them together. So put the like terms together and write them like that. Then what you'll do is you'll go ahead and combine them. So what does that mean to combine them? Well, it means that we're going to take a look at the coefficients in front of the terms. So that's positive 3 and negative 1. Now I know a 1 isn't there, but it's an invisible 1 and it is there. So 3 minus 1 is 2. So that 3 and the minus 1 combine together to give us 2. Likewise, we have positive 2 plus 3. Positive 2 plus 3, what does that give us? It gives us positive 5, and that's all there is to it. Your other two terms, nothing happens to them because they didn't get combined to make another like term, so they just stay the way they are. 5a cubed b cubed stays as 5a cubed b cubed. And negative 4a to the exponent 4b stays as negative 4a to the exponent 4b. And this, right here, of course, is as far as we can go. There's nothing else that we can do to make this into a simpler expression. That's it. That's all. That's all there is to it. All right? Okay. Moving on. The next example, or set of examples, highlights the importance of reading the instructions. There will be questions like this in your homework, where you don't have to do the question, you just have to identify the like terms. So what are the like terms? I see 4x squared. Okay. Is there another term like 4x squared? Yep, there is. It's negative x squared. Now, is there any other like terms? No, there's not. I don't think it's enough to put a box around it. And you're gonna might ask me, well, why not? Because one of the important things is understanding that these two are like terms and understanding that you capture the sign as well. So I'm going to say like terms, and you can have two different sets, but in this case there's only one set, 4x squared and negative x squared. Those are like terms. That's it. That's all for question A. I put a box around it to start with, and then we put it into a statement. I'd like you to do both of those things when you do your homework and you write your quiz next class. The next question is 2a plus 3b minus 5 plus a squared minus 3 plus c. Again, we're going to put a box around the stuff that makes, they're like terms. 2a. Is there anything else in there that would go with 2a? Nope. A squared is not the same because it's squared. 3b. Is there another term in there with a b in it? Nope. -5, is there another number there all by its lonesome? Yes, there is. -5 and -3. So when we write out our like terms, it's going to be -5 and -3. Include your signs, because if you don't include your signs, you're not doing it right. So you've got to make sure to include the signs. You might say to me, well, why didn't you include the sign on the 4x squared? Because if there's no number there, if there's no sign there, it's presumed that 4x squared is positive. You don't have to put a sign with a positive term, but you have to with a negative term. It's just one of those goofy rules in math. Now, if you want to add the positive on the positive 4x squared in question A, go for it, but you don't have to. On to question C. We have 2m squared n plus 3n cubed rather, minus m squared n plus n cubed. So this is a nice one because there's not only one set, and here's the first set right here. I'm going to box that. There's also a second set. Now I'm not going to use a box because then I'll get confused. I'm just going to do this. I'm going to double underline it like that. And I'm going to double underline this one. So we've got two pairs. How are we going to distinguish? Well, we're going to write them separately. So I'm going to say like terms. 2m squared n, comma, minus m squared n. Then below it on a separate line, 3n cubed, comma, n cubed. Okay? There you go. They're separate, so we see that we have two pairs of like terms for question C. Now for question D, we'll have, I don't know, let's see. We have 2t. We have -4t. And we have -t. Those are all like terms. So there's actually three things that are like terms there. I was going to say three pairs, but no, a pair is two, not three. So we've got three terms that would make up a set of like terms. Then we have u. We have -3u. Well, that corresponds with just positive u. So there's another pair. And then we have, I'm going to have to get a little bit creative here myself, a number by itself, a number by itself. So we've got three sets of like terms in this question. So let's write them all out. So, like terms. And we have 2t, comma, minus 4t, comma, minus t, minus 3u, comma, u. And then we have positive 9, comma, 7. And again, I don't really need the positive on the 9, but you could put it there. It's not wrong. And that's it for that question. So this question's not asking us to simplify. Instead, it's just asking us to identify the like terms. There will be questions like that on your homework assignment, and there'll probably be them on your quiz, so please be aware. Because if you start doing the whole shebang on each question, it's going to take you longer, so don't add extra work to your load. Now, we'll do some more examples here. And we're actually going to go the whole distance now. Collect your like terms and simplify each algebraic statement. So first of all, we're going to put stuff with the like terms. So we got b squared, and we should identify if there's any other b squareds. There is, minus b squared. So we'll put minus b squared. Then we would write our b's next. So b, there's no other b. So it's just plus b. And then we can look for, I'll put a little check mark, -11, positive 5. So put those on the end, -11 and positive 5. Please make sure to put the signs with the appropriate term. Then we'll simplify. B squared minus b squared. If you take anything and you subtract it from itself, you get nothing. So we get 0b squared, so we don't have to write it out. So this just turns into nothing. We have plus b, so it's just plain old b. And then we have negative 11 plus 5. That's minus 6. All of that turns into b minus 6. Okay, and the next question is big, 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 big. But there's a whole bunch of terms here. So let's see what becomes our like terms. We have a. We have another term with a. 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 Oh, next one doesn't have a in it, but the last one does. Tricky, tricky. So we're going to put all the terms with a in them together. So we have to rewrite that all out. So that's a plus 4a minus a plus 3a minus 2a plus 5a minus a minus 3a, and put the plus 5 on the end. I know the answer is going to have plus 5 on the end because we're not combining the 5 with anything else. The question is, what does it get to when we put all those a's together? So you have to kind of go through this and do the arithmetic. 1 plus 4 is 5, minus 1 is 4, plus 3 is 7, minus 2 is 5, plus 5 is 10, minus 1 is 9, minus 3 is 6. So it's going to be 6a plus 5. Final answer. Again, all we're doing is rearranging our polynomial so that all the like terms are together, and then we're simplifying. And we're off to the next question. We got 3 to go here. We've got 3e plus 7f squared minus e plus 3f. There is one pair of like terms here. It is the e's. The f's are not like terms because one's squared and one's not. So we're going to rearrange to put the e's together. 3e plus, oopsies, not plus, minus e. Then we have plus 3f plus 7f squared. And we're going to get 2e when we combine those like terms, but nothing else is like terms. So nothing else can be combined. Only the first two terms, or the terms with e in them, can be grouped together to give us 2e. The rest stays the same. And with that, we're off to our second last question of the day. So again, where are those like terms? We have 3p and negative p. We have positive 2, positive 5, minus 7. And we have negative p cubed and positive p cubed. So we have 3 sets of like terms. So we'll start off with, we should put the stuff with the highest degree first. So we'll put the p cubes first. So that's negative p cubed plus p cubed. Then we'll put the p's next. So that's 3p minus p. And then we'll put the numbers last. So that's plus 2, plus 5, minus 7. And then we'll work out each set of like terms. So if we have negative p cubed plus p cubed, that's going to give you nothing, 0, zilch, nada. So there's nothing that's left there. So we'll move on to the p's. We have 3p, take away p, and that's going to be 2p. And then we're going to have 2 plus 5 minus 7, so that's 0. So the answer for that big, big, fun, fantastic question is just 2p. And now, one last example, and that's time to get some practice in. Here it is. We have a squared b minus 3ab plus a times b to the exponent 4 plus ab minus 4ab to the exponent 4 plus ab. So again, look for those like terms. So a squared b, any like terms that go with a squared b? Nope. We have negative 3ab, any other ab's? Yep. So there's a minus 3ab, there's a plus ab, and another plus ab, and then we have plus ab to the exponent 4, and we also have minus 4ab to the exponent 4. So we have two sets of like terms here. Everything has a dance partner except for a squared b. Okay? So we got them intermingled a's and b's, so we're not going to get too worked up about how we arrange these things in what order. We might as well just do a squared b first. So a squared b has no dance partner, so it's just written out like that. Then we'll put our ab's together. So that's minus 3ab plus ab plus ab. And then we'll put our ab to the exponent 4's together. So that's plus ab to the exponent 4 minus 4ab to the exponent 4. A squared b is a loner. It's all by itself, so we don't add it or subtract it with any other term. But the ab's, we put them together, and we're going to get minus ab. And then that takes care of the next three terms. And we're off to the ab's to the exponent 4. We've got one of them, and we're subtracting 4. So that's minus 3ab to the exponent 4. And just like that, we have our polynomial written in its most simplified form. Okay, so practice these questions for your practice and make sure to show your work, show every step, and read the instructions carefully.